Hidden within and beneath the swirling clouds on Earth's surface are different forms of precipitation, from drizzles, monsoons, hurricanes to blizzards. Now, with a new generation of satellites, we can see through the clouds better than ever before. NASA and the Japan Aerospace Exploration Agency lead a constellation of satellites called the Global Precipitation Measurement Mission, or GPM, that measures all precipitation. One spacecraft, the GPM Core Observatory, tunes the constellation to one consistent note, like an oboe tuning an orchestra. If we speed things up to around 2 seconds per day, a seamless map of precipitation emerges and patterns start to form. These patterns give us vital information on where, when, and how much precipitation moves around the world. And it's the most detailed and worldwide view of falling rain and snow ever created. Red shows high rainfall, yellow and green shows medium to low. Snow is also shown in blues near the top and bottom, depending on the season. This is the first time it can be measured globally. Around the equator lies a persistent band of the heaviest rainfall. The sun is most intense here and causes more water to evaporate. The rich source of water vapor in this region fuels many tropical storms and feeds heavy monsoon rainfall and tropical rainforests. GPM can also see the driest places on Earth. Just above and below the equator, large-scale sinking air compresses and warms as it falls and thus hinders rain formation. These areas give rise to the majority of the world's deserts. Smaller regional events can also be seen. Scientists can follow the track of an individual storm almost anywhere on the globe and monitor how it develops, evolves, and intensifies. Tracking storms is also important to better understand and anticipate natural disasters such as landslides and floods. For a more complete picture of global precipitation, other parts of the climate system need to be studied, like sea surface temperature. These temperatures and precipitation are closely connected. When these temperatures change, precipitation patterns tend to change as well. Warm ocean temperatures can cause more moisture-rich air to rise and develop into rainstorms. Weather events aren't just influenced by temperatures. Winds also play a role. Winds can drive where rainstorms move, but winds can also act like a mixer, stirring ocean temperatures. Everything in the atmosphere is interconnected, and with GPM observations, scientists can analyze how different factors influence global precipitation patterns in order to better manage our water resources and predict and prepare for natural disasters.